thank you for being here. Thank you for this film. I mean, there's so much to it. I just want to start with one thing is you say right at the beginning that I'm curious what it's like for an introvert to star in a movie when you can't sit through a movie yourself. You said that right at the beginning. I thought, he's back, everybody. Ross Kaufman. What an entrance, another entrance. We'll talk about this later at the bar. But tell me about that. I mean, this must have been deeply uncomfortable, yet you're, and I hate to say it, a natural movie star.
It took Ross 9 years to make that film. And, so it evolved over time. But I mean, you should see the first time Ross interviewed me. Trying to get me to talk in front of a camera.
You said it was awkward.
It was more than awkward, yeah. And, yeah.
I had to yell at him a little bit. Basically, I asked him a couple questions. Well, it's interesting. The first thing you said when we were we did a pre-interview on the phone. That's what we do sometimes. And I said, "What are you trying to do here?" This is on the pre-interview. And he said something I've never heard anyone say seriously. He said, "Cure cancer." It's like, oh my God, I have to get that on camera. I just have to get that. And so I asked you, I said, "What are you trying to do here?" And he said, blah, 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 blah. You gave me this whole long
convoluted.
And then I said, "Okay, in a shorter amount of time, what are you trying to do here?" And you did the same thing. We went through this 5 times. And then at a certain point, I just yelled. One of those things was like a Hail Mary. I said, should I do this? And I threw the Hail Mary. I said,
we'll switch out your mic. I better one here for you.
I said, what? I said, why is it so hard for you to say you're trying to cure cancer? I just yelled at him. And that's when you had that. And that sort of made the whole interview easier.
And it is audacious, but it was also very real. You're don't seem prone to flights of fancy. You seem really well grounded, and yet that's what you wanted to do.
Yeah, I mean, I saw T cells kill people when I was, it started off in Seattle. And when you put a bone marrow transplant using someone else's T cells into the recipient, and I had this patient, her name was Bina Biddasaria, and it was awful. I mean, it was in early days of bone marrow transplant, and she had a leukemia. She was very wealthy, came from India, didn't even know she had leukemia. So this was how medicine was done in India back then. She had a wealthy husband. She was not even told she had leukemia. So she shows up here in Seattle where we did a bone marrow transplant, which is awful, high dose chemotherapy, radiation, because she had a, quote, blood disorder. So she hadn't even been told. And we ended up killing her. Because the T cells, the donor was her brother, and the T cells reacted against her. That's this graft versus host disease. So I saw, T cells in 3 weeks could kill you faster than leukemia can if they get out of control. So that then became, and then I saw in HIV 10 years later, when the virus kills it, how your immune system, the T cells are the orchestra, control the immune system. And so they have this amazing power. And then, but, what I didn't talk about in the movie is, we can transfuse blood cells, platelets. I'm a universal donor because I'm an O negative. So blood cells you can just transfuse. You can't transfuse T cells unless you have an identical twin. So we had to learn how to grow T cells. And that was the first big fork in the road. Was I had to work on HIV because in the Navy, we weren't allowed to do cancer research. So we learned how to grow T cells for the first time. That was the huge step that allowed us then to actually make the CAR T cells that went into Emily. A completely, fork on the road, completely away from cancer. It was just, but no one had worked on actually growing T cells. And AIDS was the motivation to do that because they didn't have any T cells. So then when I started working on leukemia, that ability to know how to grow T cells and then the patient's own cells, we didn't have to do the bone marrow transplant. We could use their own cells, and then we didn't have that toxicity of the graft versus host disease. So it's a 30-year odyssey that
Is ongoing.
it's ongoing. I mean, now it's now we know many, I think all blood cancers are going to be treated this way, and the big issue is how long it'll take until it's all cancers.
And 30-year odyssey, is this another 30-year odyssey? There's so much energy in this field, but it's just the administration's working on this very assiduously. It seems like this is a real moment.
Yeah, it's now, I mean, it's a classic example of a tipping point. Immunotherapy, the ability to try to use, vaccines failed for cancer for 50 years. They didn't work. There were no approved, except for virus cancers like hepatitis or cervical cancer, which is HPV. There you can prevent cancer, but there are no vaccines that treat cancer. And so people gave up on it, on the idea of using the immune system to actually cure cancer that you already had. And now, after seeing this in many kinds of blood cancer, now there's a huge amount of research doing it because it only took 3 patients. I mean, that was the amazing thing, this tipping point. There were 50 years of disappointment, but then we had 3 patients in a row that David, the adults, and people said, whoa, this maybe can work. So the tipping point thing, 3 patients, and now all of a sudden everyone thought it could work. And now there's thousands of trials. So we will, I mean,
A sea change.
It's a sea change, yeah. And it's all over the world. I mean, and so it's just a matter of when it happens, when all the, cancers like breast cancer and ovarian cancer are cured this way.
And Emily's essentially the first in all of this.
Yeah, she was the first child. And then that's very unusual. That's where it first got FDA approved because she had acute leukemia, so normally drugs get first approved in adults. And, but it turned out when the pharmaceutical industry, in my case, it was Novartis, licensed this technology, the quickest way to get it approved was acute leukemia because it kills you in months. And so the trials don't take very long to show that they work. And so that's why it ended up, the initial FDA approval was for children aged 3 to age 25, young adults. Now it's approved for any age. But initially it was pediatric and young adult.
And Ross, for you, talk a little bit about the Whitehead family and what it's been like getting to know them and how Emily is and what they're up to as well.
Well, Tom Whitehead likes to text a lot. I mean, I could text him right now. He's in Rome, and he would text right away. The Whiteheads are amazing. I mean, you can see the difference between Carrie and Tom, right? And it takes that balance. If we had 2 Toms there, it wouldn't have happened. If you had 2 Carries there, it wouldn't have happened. They're really an incredible family. Yeah, it's fascinating. I mean, Tom, you talked about one time people who don't give up. Yeah. Like there's a certain subset of people who just don't give up.
Yeah, I mean, the best example was when she was in the ICU. We didn't say all the details there. Her blood pressure was 50 over 29. And that was on the maximum amount of blood pressure agents you can give to raise your blood pressure. I mean, she was dying. And so literally they were going to make her, comfort care, do not resuscitate. Tom said no. And Carrie said yes. She thought there had been enough suffering. She just wanted to let Emily, pass away. Tom said no. She's got to recover. He's a bulldog who would never give up.
Yeah, and the Whiteheads. So go to the Emily Whitehead Foundation. They are on a mission to raise money to basically raise money for pediatric immunotherapy research, and they're helping families who are actually going through this like they had gone through it. They just had the Believe Ball. They have something called the Believe Ball in Pennsylvania, and I think they've raised almost $3 million so far.
There were 50 kids there. No, 30 families.
Yeah, you were there. I was there.
There were
wasn't
30
there. I
kids
just
like Emily
should've
there. 30 of them who would have been dead, and they came back like a reunion.
Yeah.
Folks, I'd love some, These love questions from the audience. I just want to ask you quickly before that, how is this film being used in all of this, strategically? I mean, so much of it, of course, is getting out to a wide audience, but it's also using it as its own tool in this. So talk a little bit about that, and then I'd love the questions from the audience.
Yeah. Well, our plan is to go out to universities, colleges. We have someone who is going to put it out to 30,000 different colleges and universities around the country and around the world, and we'll put it out to hospitals, and it's just the idea of impact. This film is going to make some impact.
It feels like that, and there's also the short that you can Google the short on YouTube and share with your friends.
It's called Fire with Fire, the short film.
So folks out there, questions? Yeah, right there, John.
So, first an acknowledgement and then a question. My profession is to work with people like you, doctor, and trying to get them to connect emotionally, because I think it's such a logical, right? The logic is what's working at work. And I just want to know a little bit from both of you about how you brought out the emotion in this and what you think about it now looking back on it, because I really think that this is what we need vastly more of. I think it's one of the issues we have with understanding science and having it impact policy and everything. And this was absolutely incredible. And I got to imagine, doctor, that it was hard for you.
So the question real quick, if you didn't hear it, is the emotion, how Ross, and you talked about at the beginning about the emotions of finding that and how that worked, and how did you bring it out, and scientists don't necessarily find that space.
Like I said, well, I mean, I never told you this.
Oh, here we go, everybody. First, this is very exciting.
Maybe I did tell you this.
Come on, don't just go with you've never told them that.
With the short film, we had 8 months of back and forth with the hospital because they were making your deal with Novartis. So they couldn't say yes. So every 2 weeks, Robin Honan, our amazing producer, who she, as much as I am responsible for this, would call every 2 weeks and say, can we do this film? Can we do this film? And so finally, people at Penn said yes, Penn Medicine. And I am terribly lazy about doing homework and research. And so I had never actually watched video footage of you. Did I ever tell you this? Yeah. And I turned on MSNBC where you had done an interview. And you were not great in that interview. It was
jarring.
And then I turned on another interview. I thought, oh, maybe that interview.
Bad day.
And you weren't great in that interview either. And then I was really nervous. I was like, oh my God, what have I gotten myself into? But then we talked to you on the phone, that pre-interview. And Zan, you remember Zan Parker? And Zan said, Ross, don't freak out. It'll be okay. We'll get on a pre-interview. We'll see what he's like. And not only did you say the cure cancer, but you cried 3 times on that pre-interview. And so I thought, all right, I think we'll be okay. And so my job, I think I sort of alluded to this in the beginning, is to, for me, not all I care about, but I feel like if you can't help people feel, then for me, it doesn't work. I don't know about you, but for me, I need to feel something, and then I can think about it, and then I can click on a link on a computer, but I have to care and feel about it. And that's sort of my, I guess you could say, my ethos when I make films. I want to make people feel, whether it's laughing, crying.
Yeah.
And as soon as
You're in a very different profession, sir.
yeah,
It's a
but
whole
as soon
different
as we
thing.
talked, I knew like that you had that emotional. I don't know.
I mean, I talked about, and part of the reason I went mostly into lab research was, I mean, as an oncologist, a lot of your patients die. And that, I said, it takes a coupon out of you every time. It was really hard on me. And you know, it doesn't come across in the film, but, you know, Emily Whitehouse was an only child. They couldn't have another one, you know, so if she died, that was it. And, you know, so I bonded with that. I mean, I know what it's like to lose someone close. And so, you know, it was very emotional to me, that story of what has happened. I mean, and so, and, you know, just this last sense, and then I said, like, you know, there are 30 kids that came up to see me and Lisa at this Believe Ball last Saturday night. I mean, it's amazing over these last 10 years now of how, because of Emily, I mean, if she had died, it would have been over, as I said. I mean, but it's amazing now. We see these kids every day and adults that I see, and to be alive for me to see that is, you can't imagine a better feeling, really, to know, you know, working hard for a long time and then to see that it actually made a difference in someone's life is huge. So, you know, and I'm not someone that's, I mean, I'm an introvert. I don't like to do things like, but to get that emotional, it's such an amazing connection when people come and tell you thank you, you know. So anyway, that's a blessing. It's hard to imagine something better.
And Lisa, thanks for joining us here, by the way. Give a wave over there, Lisa, everybody. Saw in
Lisa.
the film. I know. Andy, you had a question?
One little thing that I was curious about in the film, there was, after the first 3 successes, you said there were 3 failures. And I wondered if you ever found out the explanation for it.
So the question was, he said in the film, after the 3 successes, there were 3 failures. And did you ever find out the explanation?
So we did. We ended up treating about 60 patients with, you know, that was chronic lymphocytic leukemia. Okay, and Emily had the other acute lymphocytic leukemia. So when we treated 100 people, adults or kids, with acute lymphocytic leukemia, the complete remission rate is 80 or 90%. Okay, there's never been anything that high, and this is people who failed everything else. With chronic lymphocytic leukemia, it's about 28 or 30%. Okay, and we got, so basically, it's called the tyranny of small numbers. You know, you can roll the dice, and sometimes you'll get, you know, or flip coins. Sometimes you'll get 3 tails in a row, and other times 3 heads. So in chronic lymphocytic leukemia, those adults we treated, we only expect, what we now know is the true response cure rate is 1 out of 3 with what we were doing back in 2010. We now have a much better, but so it was 1 out of 3. We got lucky because we got 3 heads in a row initially, and then we got 3 tails in a row, which brought us to a 50% response rate, cure rate. And that's closer to what the true one is if you treat on. So it's just statistics. Okay, but in acute leukemia, basically they all get complete responses. So but we just didn't know that back then. It was, we thought we'd lost the secret sauce.
But you hadn't.
We hadn't, but we didn't know. I mean, it was very, I'm telling you, it was an awful feeling.
It was a miserable time.
Yeah, we didn't know. So it was really a very hard time. And then when we treated acute leukemia, they basically all got complete remissions. And so we knew that the basic procedure was working, and there's just a difference in the susceptibility of the disease, whether it's called this chronic lymphocytic leukemia or the acute leukemia.
It's wild to listen to the audience kind of murmur in the back. Eric, you had a question? Got a couple of them.
One of the beautiful story arcs that the film susses out is the conversation both of the family and the doctor in his research of the conversation with intuition. The family deciding what treatment options to pursue, depending on dreams and what felt right to them in the moment. And then, Doctor, I believe at one point you said that in your experience, science has become the art of knowing when to go deep on the unexpected. Forgive me if I'm paraphrasing. Would you talk a little bit about...
Did you take notes?
Oh,
It's
yeah.
impressive.
Doctor, would you talk a little bit about your experience, your relationship with your intuition in your research? It seems like so many dots had to be connected to finally reach this goal.
Beautiful question, Eric. Thank you.
Yeah, I mean, so for Tom Whitehead, I mean, he's a very devout Christian, and he was just believing this was God's will, telling him what to do. On those decisions he made, and the dreams he had that he thought were, and I mean, as I said, I mean, by all rights, what happened was a miracle to when I look at medically what happened to her. But so he believes that's what he believes. No, and in my case, I'm agnostic, but what I do have found out is a series of improbable events led me to this place. I mean, I talked initially, I was not even going to go to medical school. I was going to become a chemical engineer like my dad. I was admitted to Stanford, and then because of the Vietnam War, I ended up going into the Navy and then to medicine. And so I never planned that. And so that happened. That was one big fork that I didn't. And then the whole thing, I then got trained in bone marrow transplant because the Navy they were worried about Fukushima, like what's happening in Ukraine maybe, with nuclear reactors, because the Navy has a lot of submarines. That's why I was trained in leukemia. And then, but then, the Navy is not allowed to do cancer research. All by the federal law, all cancer research comes through DHHS, the National Cancer Institute, to direct congressional appropriation. And the Navy's only research that they're allowed to do is infectious disease and combat casualty trauma. So I worked on initially malaria and then HIV. I didn't plan on that. I was trained in leukemia, but the only research I could do once the Cold War happened was was HIV. And that turned out to be a huge blessing, because then I knew how to manipulate the HIV virus and turn it actually, instead of a disease-causing virus, into a tool, that makes T cells, become cancer specific. So that was completely unplanned. Okay, that was number two thing. And then my wife, when she got cancer, I mean, I was trained as a medical oncologist, but to see what happened, and it really made me want to, because I had published hundreds of papers by then on basic science things, but not actually ever once treating a patient. And when my wife got sick and stuff, that's when I said, okay, I'm going to go from doing mouse experiments and all this, and actually we're going to do this in humans. And so we actually made the first CAR T cells that we treated. Those patients had AIDS, and we used it to make their T cells better. And then we started to do it in the leukemia patients in 2010. And so I had a whole series of things that happened that led me to have insights that if I had been, say, a cancer researcher the whole time and hadn't spent 10 years doing HIV, I would have never known that. So there was a lot of serendipity. I mean, that's why I talked about Alexander Fleming and this accidental discovery of penicillin. And so luck has a big part in timing in discoveries. And I had that several times in my career.
So I was just
Sarah,
going to
you
say.
want to jump in real quick?
Yeah, I was just saying, wasn't it your daughter who had the arthritis that then you tried to treat when Emily was crashing with the...
So I'll tell you more about that. So my daughter Sarah got juvenile arthritis, and the one FDA-approved drug was tocilizumab, and so that's in the movie. That I knew about that because I was basically doing a tech watch, and, for my daughter. So a funny story about that. My daughter, then, she went to Harvard and she majored in the history of science. And she took this class. This is
Was it history in the quotes making it
history of science.
right?
And so that in that class, the professor started off with a story that he'd learned out of the New York Times, where Emily Whitehead was treated, for this. And I didn't say in the movie, she had a fever of 106 degrees for 3 days. That's how hot. I mean, was not caused by an infection. That was caused by the T cells killing her cancer, and there's a whole lot of inflammation. 106 degrees. That's how high it was. So, and that's why we were so desperate to find something, because nothing else worked. And so then it was miraculous how it worked. But at the end of this, the professor talked about the story, and then about how, because it was in the New York Times, because I told the person who wrote the article about that, because his daughter had arthritis, gave tocilizumab to Emily, and then it worked. And actually, the FDA then, when they approved the CAR T cells for leukemia, they co-approved tocilizumab to treat the side effect of fever, and that's never happened. Wow. And with a co-approval like that. But anyway, so my daughter Sarah goes up after the lecture and says, "Well, I'm the one you were talking. I'm the daughter."
Hey, there's so many.
Arthritis.
There's so many more questions out there. We're gonna have to wrap it. I have one more. Before I do, these guys will be downstairs. We'll have a drink downstairs in the show bar. Come join us for that. It's a really lovely spot. We also have so much cool stuff tomorrow, and that you really want to check out, especially stuff in the morning. There's sign-up sheets for Yoga Nidra with Tom Voss, which I highly recommend. And then there's a Bear Creek hike, and then the Women's Circle. What else am I missing, Meredith? Anything else, Laura? Okay, cool. So make sure you sign up for those. And tomorrow afternoon, there's a show called Power of All, which relates to the question that I want to ask you. And the Power of All is really, how do we process so, I'm not going to explain it well, you read it in here, but it's a really beautiful show. And it's basically comes back to something that I think you're really interested in, which is the power of nature. I had the pleasure, I took a little time out to pick up Lisa and Carl up at the airport today. And as we were driving in, they're both out the window looking and sort of stunned by this. And in the film, you say, this takes a chunk out of you. You mentioned that earlier up here. And I have a feeling that in a way you get refueled through that connection, away from the lab and away. Can you talk about that a little bit?
Oh, yeah. I mean, the one time I can really turn off the brain and this constant stream of thoughts that I always have is I've done a lot of ultra marathons and ultra bike events, so 50-mile runs and race and all those. And when I do that,
Now you're just showing off.
but when I do those, it's a way to have the brain at peace.
Yeah, makes a lot of
He
sense.
does these things called death rides. I mean, who would have thought?
Not even. Ross Kaufman, Carl June, original thinkers. Thank you. Let's all go downstairs, get a drink. Appreciate you guys.